Good morning. And for those joining from California, really appreciate you guys joining in this early. So as David mentioned, the name iuno is something that is actually quite personal to both Ashwin and me. The word iuno has Latin roots. It's basically saying it's saying I uno, that is, there's only one of you. And the reason for this is we believe that today the way healthcare system is presented to an individual is that there is a sort of, whether it is healthcare or wellness, there is this whole idea of one size fits all. And what we really want to do is understand, get to your DNA and your proteins to really understand why and how this is individualized to a person, and not just understand the problems that this person's going through or concerns or their health status, but really provide them with a solution that actually can course correct and help them stay healthy longer. So that's really the premise of iuno, and that's how Ashwin and I got started on this. Now, really, there is a very there's a sort of a deeper connection for us. Ashwin's also my partner of about 12 years now and counting. So for us, it was, it's been a really long journey. This was back in 2014, and I was still a graduate student at Caltech, and I was diagnosed with leukemia. Now, the problem with this was the diagnosis itself. It took about a year and seeing about, half a dozen doctors, different kinds of doctors, to really get to the diagnosis. And this is because every time a symptom was being presented as something else, right? Whether it was issues with my skin or issues with breathing or issues with my muscles. So there was every time it was a different doctor. And so getting to the root cause of what was creating these issues for me was really hard. And because of that year-long delay, my prognosis was much worse. The medication I needed to be on, the dosage was higher. Getting to that dose was more difficult. So everything kind of became difficult at that point. And so for Ashwin and me, it was one of those things where we realized, okay, we are probably not the only ones going through this. Most people who get a hard diagnosis have gone through a similar journey. So is there a way that we can solve this problem?
More recently, so I was working at Caltech as well, and then I was also briefly at Google, and then just started my lab at MIT. And in between, so the technology that I was working on was organizing single molecules with semiconductors, and there was a direct utility of that for single molecule protein counting. And the way in which we started seeing this was there is increasing amount of papers coming out that talks about how proteomics allows you to get a snapshot of an individual's health right there, then and now, not necessarily very differently from how you look at healthcare from a genomic or transcriptomics sense. Like those give you probabilities of certain things happening, and transcriptomics is sort of gives you a little bit nearer term picture, but it doesn't tell you exactly what's happening in every part of your body. But there is increasing evidence that looking at the high dimensional data that comes out of proteomics, wherein you're looking at patterns of 10 or 15,000 different proteins, that can correlate to all the phenotypical information about an individual, whether they sleep well, whether their organ systems are working fine, what are their homeostatics function, all of that. But the real problem, so it's very comparable to the state that genotyping was in the 90s and the early 2000s, wherein it's clear that there is some information in looking at the genotyping information at a population scale and looking at patterns and saying something about a genetic underlying cause for certain conditions. But what does that look like for the proteomic space? How do you collect large amount of data and phenotypical data of individuals and make sense of it? Our proposition was that it is not going to come from necessarily NIH or somebody funding, several billions of dollars and doing these kind of population studies. So we started looking at what would be the way in which we can get it from can we come up with a business model that builds on top of these existing proteomic tools, and as the cost of the proteomic tools come down, this will have more and more an outsized impact. So we'll be there with data to kind of go after this this wide variety of healthcare utility. So the underlying premise is you are unique. Your proteome tells you everything about your phenotypical condition. But then the question becomes, how do you wrap a business model around this? And right now, the cost of the proteomic analysis is also a little bit on the higher end, but it is comparable. In fact, it is cheaper than what it was when these commercial genomic companies like 23andMe, Invitae, Ancestry.com, all of those things started. The cost of the genomic analysis or genotyping analysis was much more, almost an order of magnitude than more than what it is for the proteomic analysis right now. So we were like, okay, this is the right time. Let's think of all the ways in which we could come up with data collection and build a business model around it, and wherein we are delivering value while also collecting the proteomic information and the phenotypical information or associated with that particular proteomic sample.
Now, this team sort of came together to really understand, okay, where is it that we can apply this amazing technology? We have this business model. Now we need to find our early adopters, right? People who would actually validate this business model for us. And so that's how we started with skin, because one, skin is, it's the largest organ. It is something that's most accessible. And it sort of gives you that instant gratification, right? When things change, you see it in person. It's not like your heart that you measure. It takes a while for it to change, and you don't really know other than some numbers that your doctors tell you. There isn't that warm, fuzzy feeling that, oh, there's something here is changing for sure. So not that heart's not important, but we figured that, going skin first, we had a significant advantage over going through any other path. So with skin, what we have proposed is this whole iuno protocol, wherein we send, it's a 3-step process for the individual. We send a home-based test kit, and then we analyze the proteomics based on the sample, the biological sample that they send back to us. And we create a 3-month treatment plan for them that's delivered to them month to month. And they are able to then also observe whether how their treatment is progressing with the app that we have. So they go through this entire circle with us, and we bookend the treatment plan with 2 proteomic tests, one in the beginning and one in the end. Now, the whole reason for us to get this going is to think about, how do you create a consumer-powered healthcare data flywheel, right? So what we are getting are people who are willing to share this information with us because they want to understand what's going on with their skin. They want to get their what's going on with inside their body. They want to understand this, and they want to get it to go better. And so we obtain genomic and proteomic data from them, as well as behavioral data, because we have the app that collects their pictures of their face, as well as we have some questionnaires that we track to understand what their regular behaviors are and when they deviate from their lifestyle choices and so on.
Well, and one thing I didn't appreciate until we started talking about what you guys were planning on doing was just, and hadn't really thought of it, is that the skin is the largest organ of the body, and there's so much importance to it that I don't think I really appreciated, because I know that when we first started chatting, I mean, it's actually fairly common for companies that were, or scientists that we're talking to, they're not quite companies usually when we first meet them, but like a lot of times, because it's that basic research foundation actually is such a core component to being a Caltech researcher, that it almost enables this platform perspective where you have a few different options at your disposal. You're like, I could do skin, or I could do this other application. So either way, it was interesting to understand why you chose skin, and yeah,
and skin is also, if we are looking at healthcare or any of these interesting deep tech, one of the things that we started noticing was adoption of deep tech starts with essentially sectors and use cases where the cost of failure is relatively low. If the cost of failure is very, very high, then it will take a long time for the adoption wherein you can prove it out. But because we are looking at skincare, wherein, thankfully, there is no science-backed skincare right now. It's all anecdotal. So any improvement has an outsized impact. So in that, while we are going through that, we can work out all the problems associated with data collection, data handling, looking at what is the best ways to curate the data and make sure that it is useful for downstream applications, wherein you can draw out insights that are beyond skincare, and we can do it in a sort of cash burn, I don't want to say neutral, but as neutral as possible. We don't need to burn a lot of cash collecting that data. From day one, we were trying to view it that way, because you can see European governments as well as several other governments are starting proteomic data collection campaign. It's not yet started in the US yet, but the problem with data collection campaign is they are looking at it, comparing it to genomics, wherein it's a static data, but proteomics is it is evolving with time. So you need to factor in not only the horizontal population scale data collection, but also longitudinal, which increases the cost dramatically. And our hypothesis is that I don't think any government is going to catch up to that. So let's think of like a really market solution to some of these things and build a business model around it, so that if we can sustain it there, then it will sort of really put us in a pole position.
David, maybe I'll ask a question. Just Ashwin, if you and Anu could elaborate a little bit on some of these other downstream applications as you move from skin, and then you add women's health, and then you add immune disorders and so on. It certainly resonates with me that there's there are no longitudinal proteomic based databases at scale, and that longitudinal aspect captures the dynamic aspect of proteins versus the stability of a gene and a genome. So maybe just elaborate on sort of where this is all going, because the women's skincare business can be a profitable, high growth business in and of itself. But I think you aspire to greater things as you build this database over time.
So I think the model that we are building with iuno protocol, which is you do the test and you get solutions under one roof. We want to try keep that going as long as I really like providing closed loop solution to the people who are in our ecosystem, right? So just thinking about that for a minute, we've now, when you think about lifestyle medicine, it's something that's really growing as an area, whether it is for obesity or metabolic disorders and so on. There are drugs that are coming out that are, like GLP-1 medication and so on. So there's some interesting areas that are coming to market there, which are in this whole evidence-based wellness. So to Ashwin's point, there is so much fertile ground for us to really play in right now, where we combine our diagnostic approach with our therapeutic approach, bring in the right kind of partners.